Okay, we want to talk about Newton's laws a little bit, and the first thing we want to talk about is the first equation, which is F equals ma. And the thing you need to know about this is that this is an unbalanced force. We talked about it often about F equals force applied, whatever's applied to it, minus a force due to friction, where friction, this is defined by force due to friction equals the coefficient of friction times force normal. And force normal is the force that is perpendicular with the surface, and in most cases when things are flat, it's W. So when we look at this right here, we're talking about an unbalanced force, and we often refer to it as a net force. Force net. Quite often that's what we'll refer to it as. So that's if something's kind of in the air or wherever. Now we're going to talk about what if something's in the air. A lot of times what we talk about is we talk about F equals F force applied minus the weight, because the weight's pulling in the opposite direction. So we have a rocket engine pushing up in this direction. We have the weight pushing down in this direction. And remember that weight is mass times gravity. Okay, now we're going to talk about what happens when we are on a ramp. And I can't draw a ramp very well. There we go. I set something on here, and it's going to go down the ramp like that. And that's what we're going to talk about right now. Let me figure out how to clear this all out here real quick. I go back to the last one, I know that. And actually, I think I can do this. Yeah. Now, I want to look at this. This is a picture of a ramp. Okay? And there's a lot of stuff on this picture, but I want you, and I've got this in StudyWiz as well. This is an object right here that is sitting, this object right here is sitting on a ramp. And there are three forces. There's gravity straight down through the ramp. There's force normal, and we often call that perpendicular. And there's force parallel. So if the question was, how fast is this thing going to slide down the ramp? It depends on two factors. It depends on this angle, theta, and it depends on the weight of the object, okay, to some extent. So when we look at the force that's going to pull it down the ramp, the force that is going to pull it down the ramp is force parallel right here. That is the force that's going to take this object down the ramp. Now what's going to oppose it is friction. So let's look at theta right here. Okay, let's just look at theta. Theta exists right here and a 90-degree angle here. So if we were to look at what this angle is right here, it'd be 90 minus theta. Okay, it'd be 90 minus this angle. 90 theta, 90 minus the angle, you add them up, that's 180. If you look at the face and this line and force normal, that's 90. So 90 minus theta occurs here. Theta must occur here. So now we talk about a rearrangement where we pick this up, this vector right here, and stick it down here and close the triangle. If we do that, so we take this guy right here and we pick him up and come down here with him, The 90-degree angle is right here. Theta is right here, and this is 90 minus theta. So if we do that, when we go to calculate these forces, we use a little of our trigonometry. Force parallel is sine of theta, whatever the sine of the angle is, times weight. That's what it is. The normal force, or the parallel force, is cosine of theta times W. Think of this triangle going this way. So cosine is the adjacent side, and this is the hypotenuse, with this triangle down in this arrangement. Here's theta, here's the opposite side, which is force parallel, and here's the adjacent, which is force normal, or the perpendicular force. So cosine of that equals Fn. Well, how come this is important? Because I just messed up. The force due to friction is the coefficient of friction, whatever that is, times force normal. And the net force acting on this object, then, is the net force equals force parallel minus force due to friction. I will give you this sheet with these equations on it. I will give you this. It's in StudyWiz someplace. Okay, I will be giving you this soon. Actually, it's connected to your work for Monday. I will be back on Tuesday. You have a big concept development packet along with everything due in the end of the chapters. I'd like all that on Tuesday. I'm going to post this. It's Friday night. Just to let you know that there's some work to do. If you don't get through all the concept development packet, we'll be working on that on Tuesday as well. So have yourselves a good weekend. We'll talk to you later.